Okay, Mason, I apologize. My recording software is not working, so I'm just going to do it through a video like this. So I'm going to look first at number 2 on your handout paper, and I'm going to look at how we could write equations for that. So first of all, if you are writing a sine equation or a cosine equation, the things that we saw were the same, were the A or the B. So remember, over here for a minute, that when we talk about the A, that specifically can be found with the amplitude. When we talk about the B, it's related to the period, but it's not the exact value of the period. Okay? And so they're both going to have those same values. The H in the equation is what we're going to kind of view as the horizontal shift. So we want someone to use that as the starting point of a cycle for sine and for cosine, okay? And for sine, remember that you want to look for something that's on the midline of the function and goes up and goes down. That's how our parent function looks without any transformations. And then for our cosine equation, it starts at the maximum and goes through. Now back to the maximum. Now they both keep going and end up looking the same, like those wave-like features. But when we're looking for the starting points for them, like our H values, that's what we're going to use, okay? So when I look at this graph here, okay, and I'm looking at this function, let's say I was going to write a sine equation and I kind of view the starting point here, and I view that as like one cycle of the graph, okay? So I can see my amplitude values line up at about 0.1, meaning this graph reaches 0.1 above or 0.1 below the midline. So for this graph, I would determine my A value equal to 0.1 because of the amplitude. Okay? And that would be true for both the sine and the cosine function. Because what I've looked at right here is a sine function, I could say that this would be one good starting point for a sine function, and it lines up with this point right up here at the timeline, which appears to be between 5.040 and 5.050. So I think this is 5.045. So my H value, specifically for the sine equation, is going to be 5.045. Okay. So I have an A value, an amplitude that could work for both sine or cosine depending on how you look at this wave. The H value is specific to the sine wave because it's where I saw a sine function starting. Now I could identify a cosine one. Let's say I decided to say right here to right here is where I best saw a cosine wave from maximum to maximum. Then I would look at what this starting point lines up with, which seems to be, this is 70 and this is 80. So in here is 5.075. It looks like maybe mine goes to 5.078. So I'm going to say the H value where I've identified the beginning of a cosine cycle is 5.078. So from there, we're going to go on and then talk about the B value, okay? So the B value is related to the period but is not quite the period. So what we talked about earlier is that because we're writing sine and cosine graph equations, we know that the original period for any sine or cosine function is 2 pi. And that period is adjusted by some sort of horizontal compression or stretch, which we don't know right now, so we're going to call x. And that would give you your new period. Okay. It might feel like you don't know the new period for this function, but remember there's a relationship that you want to be very aware of. The frequency is the reciprocal of the period, which means we know if the frequency is 194.3, that the period is 1 over 194.3. So that would be my new period. And then what I would do is I would go ahead and solve this equation for x. So I'd cancel out the 2 pi and then also multiply it to the other side, and I see that I get that x is equal to 1 over, let's see, I'm doing the multiplication, 388.6 pi. So that was my horizontal compression, which means that my b value for the equations is the reciprocal of that and will just be 388.6 pi. Okay, so this b value will be the b value that would affect the period length for either the sine or the cosine. The amplitude a value of 0.1 would affect the height of the waves for both the sine or the cosine, and the h's are different because we view the starting point of a sine wave different than we view the starting point of a cosine wave. So for my final equation for sine, I would put together y equals my a value, and then I would use sine, and then my b value, which we determined was 388.6 pi, and that would be multiplying my x minus my h. Okay. My cosine equation will look almost exactly the same because remember, amplitude is measured the same whether you call this a sine or a cosine wave, and the period is measured the same whether you call this a sine or a cosine wave. So the only thing that's different is this h value, where I view the starting point differently for a cosine than I do for a sine wave. And so that's how I would do number 2.